Welcome to day 29 of our low-level design course. Today, we will be discussing the design of an online shopping cart system. An online shopping cart is one of the core components of any e-commerce platform, allowing users to collect products, apply discounts, and complete purchases. Throughout this session, we will explore the design of a shopping cart, covering everything from class design, operations, and relationships to the application of design patterns and handling edge cases. We will also discuss how to design a system that's not only functional but also scalable and maintainable as the platform grows. Before we jump into the system design, let's first look at the core components of the shopping cart. The user component is crucial because it represents the customer who interacts with the cart. Each user can have their own cart, which allows them to manage their items. The product components is what the user selects to add to their cart, and it holds details like the product name, price, and quantity. The cart class will hold all the cart item objects, each representing an individual product in the cart. The inventory service checks the stock to ensure the product is available before it's added to the cart. The discount coupon is used to apply discounts, while the order component is responsible for converting the cart into a purchase when the user is ready to check out. Lastly, the payment service handles the payment process, which completes the transaction once all validation steps are passed. Now that we have an understanding of the components, let's take a closer look at these class definitions. The user class will typically store user-specific information like their ID, name, email, and address, while along with methods for actions such as logging in, logging out, and adding or removing items to or from the cart. The product class represents each item that can be added to the cart, including details like product ID, name, description, price, and available quantity. The cart item class is crucial in linking the product with the cart and provides functionality like calculating the total price based on the quantity added. The inventory service ensures that the cart can only contain available products by checking the stock. The payment service is responsible for taking care of all payment related operations from validating payment methods to processing transactions securely. Finally, the order class converts the cart into a completed purchase, creating an order history entry and preparing the system for shipping. The key relationships between these components form the backbone of the system. The user has one-to-one relationship with the cart. Each user has exactly one cart at a time. The cart class in turn holds multiple cart items, establishing a one-to-many relationship. Each cart item refers to a product, so we have a many-to-one relationship between these two. The cart also interacts with the inventory service to ensure that the user can't add products that are out of stock. The payment service comes into play during the checkout process and is responsible for managing the payment, ensuring that the transaction goes smoothly. After the payment is successfully processed, the order component is responsible for completing the transaction and generating the necessary order records. Let's now discuss some of the important operations of the shopping cart system. The add product to cart method checks if the product is available in stock and adds the product to the cart, either by increasing the quantity of the existing item or adding a new cart item. The remove product from cart method is used to remove items from the cart, either decreasing the quantity or completely removing the item if the quantity reaches zero. The apply discount method verifies if a discount coupon is valid and then applies a discount to the total cost of the chart. Lastly, the checkout operation performs several checks. If it validates that all items in the cart are available, confirms that no discounts are misapplied, and interacts with the payment service to process the payment. This method also generates an order once payment is successful and reserves stock accordingly. In the design of our system, several design patterns play a critical role in ensuring the system is both flexible and scalable. The singleton pattern is applied to the inventory service, ensuring that there is only a single instance of the inventory across the entire system, which prevents conflicts and ensures data consistency. The strategy pattern is implemented to support multiple payment methods, allowing the payment service to switch between different strategies like credit cards, PayPal, or even cryptocurrency based on user performances. The observer pattern is useful for sending notifications like confirming an order, updating the user on the status of their cart, or informing them about shipping. The factory pattern is used to dynamically create different payment methods, adding flexibility to the checkout process without altering core business logic. When designing this system, we must handle several edge cases to ensure the system is robust. For example, if a card remains inactive for an extended period, it should automatically expire and be cleared to prevent abandoned cards from cluttering the system. If a user tries to add a product that is out of stock, the system should display an appropriate message. When dealing with multiple discounts, we need to carefully handle how different coupons or promotions interact with each other. Some discounts may be mutually exclusive, while others can be stacked. Concurrency is another important factor to consider. What happens if two users try to access the same product at the same time? This requires handling race conditions. Finally, if a payment fails, we need to ensure the system reverts any changes like reserving inventory or adding products to the order and presents a clear error message to the user. Here is a visual representation of our class diagram. As you can see, the user class is connected to the cart, and the cart contains multiple cart items. Each cart item is associated with a product. The cart communicates with the inventory service to check availability, and the payment service is called to process the transaction when the user is ready to check out. Finally, the order class is created when the payment is successful, marking the completion of the user's shopping experience. This diagram provides a clear view of how each component interacts with the others in the system. As with any system design, it's crucial to follow clean code practices. The single responsibility principle should guide the design of our classes. Each class should have one primary responsibility. For instance, the user class should only handle user-related operations, while the payment service should focus solely on payment processing. Additionally, classes should be small and focused, with each method having a clear and well-defined purpose. Error handling should be built into every method, especially for critical operations like adding products to the cart or processing payments. Additionally, consistent naming conventions and proper formatting will make the code more maintainable and easier for other developers to read. For today's homework, I would like you to create a complete class diagram for the shopping cart system using a UML tool like LucidCart or Draw.io. This will help you visualize the relationships and the design of the system. Additionally, please write pseudocode for the following methods: add item to cart, apply coupon, and checkout cart. This will allow you to practice translating high-level concepts into detailed executable steps. As an optional challenge, extend the shopping cart system by adding two new features. First, implement support for gift cards. Users should be able to apply gift cards to their cart during checkout. Second, add a wishlist feature where users can save products for later, even before adding them to the cart. This challenge will give you a chance to practice extending the functionality of an existing system and integrate new features into the architecture without disrupting the overall design. Thank you for your attention.